Okay, so mutually exclusive and overlapping events, as the notes say, mutually exclusive cannot occur in the same trial of an experiment. So right here on the Venn diagram, you have event A that are 2, 4, 6, 8, 10, 12, and then event B, which is 3. So if you roll a dodecahedral number cube, so a 12-sided dice, what's the probability that you roll and the result is an even number or a 3? So when you take a look at that, you to get those, you can see that they don't overlap at all. You've got 2, 4, 6, 8, 10, 12. So over here, and that does not overlap at all with the 3. So when you go to calculate that probability, here's how we're able to calculate it. So the OR is a union. So we need the probability of A, which is out of 12 numbers, we've got 6 out of 12. And then for the 3, we've got 1 out of 12. So we would be adding 6 out of 12 plus the 1 out of 12. So we would get 7 out of 12. Because remember, you've got fractions, and all you do is add the top and keep your denominator. So this is your answer right there. So that is mutually exclusive events because there is no overlap. We don't have an intersection right here. When we have some overlap, we need to account for that. So remember, as we were writing the union yesterday, we didn't list the intersection part twice. We only did it once. So if we look at overlapping events, let's say we tossed that 12-sided number cube, that dice again, and we want to see what is the probability that we roll and get an even number or a number greater than 9. So even numbers, 1 to 12 are 2, 4, 6, 8, 10, 12. And then out of 1 to 12, greater than 9 is 10, 11, 12. So then that probability. So for the first part, we have 6 numbers again. So we have 6 out of 12. If you look down here, this probability, we need to find the probability of A, and then we need to find the probability of B. And then this is called the addition rule for overlapping events. We need to subtract out this intersection because 10 and 12 are not only greater than 9, but they are also even. So we need to account for that. Those repeat, those are our intersections. So our event A, the even numbers, we have 6 out of 12. We're going to add to that our event B, which is 3 out of 12. And then we're going to take out the overlapping intersection, which is 2 out of 12, so that we can get our total probability, our union of A or B. So we've got 9 out of 12, and then take out 2 of that, so we have 7 out of 12. All right, so that takes care of our mutually exclusive and overlapping events. So we have that mutually exclusive rule. Oops. And then you've got your addition rule for overlapping events. Now, let's take a look at reading that with two-way tables. So here's a two-way table. You might be given your data this way. So here's what happens, some data taken on people who have a headache or don't have a headache, and where they took medicine or not, and some totals. So here's people with no headache or have a headache, and the total, people who had no headache, those totals, and then who took medicine and did not, and all total there. All right, so here's the probability. We're wanting to find the probability of having a headache or no medicine. So first, to calculate that, we need the probability of a headache or no medicine, the probability of the headache, the probability of no medicine, and the probability of headache and no medicine. So let's look here. The probability of having a headache is And we need all headaches. So that is 24. And what is the total out of all? That's out of 100. Plus, we need to have the probability of no medicine whatsoever. So they didn't say, with headache, no headache, whatever, just absolutely no medicine. So that is 40 out of 100. And then we need to take out this intersection. Okay, we're going to get the union altogether of headache or no medicine, but we're going to get the intersection of those two. So let's look at where we have a headache and no medicine. So that is 9 people. So we're going to take out that 9 out of 100. All right, so what does that give us? All right, so 24 plus 40, that is 64. And if we subtract out 9 out of that, that would be 55. And that is the probability that you had a headache or you took no medicine. And that is mutually exclusive events and overlapping events, and that is how we calculate probability. So let's go over questions and go over two-way tables and go on from there.